Welcome to episode 38, Migration Terms, Rehost to Reimagine, where we unpack the vocabulary that defines cloud migration strategies. Moving workloads to the cloud is not a single act, but a spectrum of approaches, each suited to different goals, timelines, and constraints. Understanding the terminology, rehost, replatform, refactor, re-architect, and beyond helps teams align effort with value. These terms represent trade-offs between speed and transformation, cost and flexibility, risk and reward. By decoding them, you can design a migration plan that meets your organization's readiness rather than forcing a one-size-fits-all solution. In this episode, we'll walk through each path, clarify when it makes sense, and show how disciplined choice turns migration from disruption into acceleration. Rehosting, often called lift and shift, is the simplest way to move applications to the cloud. It involves transferring servers or virtual machines largely unchanged from on-premises infrastructure to cloud infrastructure as a service environments. This approach emphasizes speed and continuity, getting workloads running quickly without code modification. For instance, a financial reporting system might be rehosted to reduce data center footprint while retaining existing configurations. Rehosting delivers immediate benefits like reduced hardware management and improved scalability, but it rarely optimizes cost or performance long-term. It serves as a tactical first step, especially for legacy workloads nearing hardware refresh cycles. The main risk is stopping at rehosting instead of evolving further once stability is achieved. It is best viewed as a bridge, not a destination.
Relocation is similar to rehosting, but focuses on moving existing virtual machines as is through migration tooling, often using features like Google's VM migration service. Unlike rehosting, which may involve building new instances and redeploying applications, relocation automates transfer at the hypervisor level. This preserves configurations, network settings, and dependencies, minimizing downtime. For example, an enterprise might relocate dozens of Windows servers overnight using replication and cutover phases. Relocation is ideal for organizations that want minimal change while exiting on-premises data centers quickly. It streamlines transition but does not modernize applications or architecture. Once workloads are stable in the cloud, teams can assess optimization opportunities such as managed storage, security enhancements, or elasticity features unavailable in static environments. Replatforming takes modernization one step further by moving applications to managed runtimes or platforms without altering core functionality. Instead of maintaining virtual machines, teams adopt managed databases, application servers, or container services that reduce operational overhead. For example, shifting from a self-managed MySQL instance to Cloud SQL keeps the schema and logic intact but eliminates patching and backups. Replatforming delivers efficiency through managed services while retaining compatibility with existing code. It balances risk and reward, more change than rehosting, but less than refactoring. This path is common for organizations seeking incremental gains in scalability, security, and reliability without full application redesign. It turns migration into modernization at a manageable pace. Refactoring modifies code or architecture to better exploit cloud capabilities. It involves partial redesigns, often to adopt microservices, APIs, or serverless components that improve performance or maintainability. For instance, a batch processing job might be refactored into cloud functions that scale automatically, reducing idle costs. Refactoring demands more engineering effort but yields greater long-term flexibility. It suits workloads limited by rigid designs, outdated frameworks, or frequent scaling issues. A common misconception is that refactoring always means high complexity. In practice, teams can refactor incrementally, isolating and upgrading critical components first. The result is a more adaptable system built to evolve alongside business needs while preserving much of its original logic. Re-architecting transforms applications fundamentally to embrace cloud-native principles. It goes beyond optimization to reimagine how the system delivers value. Monoliths may be decomposed into microservices. Tightly coupled components are replaced by event-driven pipelines. For example, an online marketplace might replace synchronous request handling with asynchronous messaging for resilience and scale.
Re-architecting demands significant design and development investment, but it unlocks the full benefits of elasticity, automation, and continuous delivery. It is best pursued when existing applications cannot meet performance, agility, or reliability expectations even after refactoring. The payoff is strategic. Systems that scale dynamically, recover instantly, and integrate seamlessly with emerging technologies across the organization.
Rebuilding is the most comprehensive reinvention, rewriting an application from scratch using modern languages, frameworks, and cloud services. This approach is chosen when existing systems are too outdated, fragile, or inefficient to repair. Rebuilding enables clean slate design free of legacy constraints. For instance, a decades-old supply chain platform might be rebuilt using serverless architecture and managed databases for better cost efficiency and integration. The advantage is total alignment with current needs. The drawback is higher upfront effort and testing. Rebuilding should follow clear business justification when functionality gaps or maintenance costs of the old system exceed the investment of starting anew. It represents renewal rather than migration, the chance to build for the next decade instead of patching the last one. Replacing moves from custom-built or self-managed software to software as a service (SaaS) solutions. Instead of maintaining your own instance of an email, HR, or CRM system, you subscribe to a fully managed offering like Google Workspace, Salesforce, or Workday. Replacement suits commodity functions where differentiation is minimal and vendor solutions outperform internal alternatives. The payoff is reduced maintenance, automatic updates, and predictable costs. For example, replacing an on-premises ticketing tool with a cloud help desk eliminates hosting and upgrade burdens. The trade-off is customization. You adapt processes to the service rather than shaping software entirely around legacy workflows. Replacement is modernization by delegation, letting specialists handle functions that no longer define competitive advantage. Retiring applications removes what no longer serves the business. Over time, mergers, automation, and process changes leave redundant systems behind. Decommissioning them reduces cost, complexity, and risk. Before retiring, teams must analyze dependencies to ensure nothing breaks downstream. For instance, an old reporting tool may still feed data into active dashboards. Deletion follows documentation, data archival, and verification steps to preserve compliance. Retiring is often overlooked but offers some of the highest returns per effort. Every system removed simplifies maintenance and licensing. Modernization is as much about subtraction as addition, ensuring energy focuses on systems that deliver measurable value rather than those that simply persist. Retaining on-premises systems remains valid when constraints outweigh migration benefits. Legal requirements, latency sensitivity, or hardware dependencies may justify keeping certain workloads local. For example, a factory control system that interfaces directly with physical equipment may need on-site hosting for safety or performance reasons. Hybrid strategies allow retained workloads to coexist with cloud systems via secure interconnects and shared authentication. Retention does not mean stagnation. It means deliberate stability for the right reasons. The key is periodic review. What must stay today might migrate tomorrow as regulations and capabilities evolve. Thoughtful retention completes a balanced modernization portfolio rather than contradicting it. Selecting a migration path for each workload depends on its drivers, business value, technical complexity, and risk tolerance. No single strategy fits all. For mission-critical systems, minimizing disruption may take precedence over transformation, while for high-growth digital products, agility may justify deeper change. Decision matrices help compare factors such as scalability, dependency chains, and expected lifespan. For example, workloads with predictable traffic and stable requirements may only need replatforming, while those demanding innovation or competitive differentiation merit refactoring or re-architecting. The goal is alignment. Each workload follows the path that delivers maximum benefit with acceptable risk, not uniformity for its own sake. Every migration strategy involves trade-offs in risk, cost, and timeline. Quick lifts minimize upfront expense but may prolong long-term costs through inefficiency. Deep redesigns create sustainable architectures but require more funding and skill. Balancing these factors means considering both short-term needs and strategic horizons.
For instance, rehosting might stabilize operations this quarter, while refactoring positions the organization for next year's goals. Estimating total cost of ownership across 5 years clarifies which approach produces the best overall return. Migration success is not speed alone. It is enduring value created through thoughtful trade-offs and transparent evaluation. Governance, pilots, and metrics ensure migrations remain controlled and accountable. Governance gates validate readiness before each step: security reviews, data protection checks, and compliance verification. Pilots test methods on limited workloads to reveal challenges early. For example, migrating one department's application before enterprise rollout allows fine-tuning of automation scripts and playbooks. Metrics such as downtime, defect rates, and performance gains quantify success. Post-migration reviews capture lessons for future waves. Governance transforms migration from a project into a process, repeatable, transparent, and auditable. The combination of oversight and experimentation builds both confidence and competence, essential traits for sustained modernization. The right migration option at the right time creates momentum instead of disruption. Each path Rehost through Reimagine serves a purpose depending on context, constraints, and ambition. Migrations succeed when guided by clear goals, honest assessment, and disciplined execution. Some workloads need speed, others demand reinvention. What matters most is intentional choice supported by governance and measurement. When organizations migrate thoughtfully, they preserve stability while gaining capability, turning transformation from a gamble into a steady climb. The journey from Rehost to Reimagine is not a single step, but a continuous rhythm of renewal that keeps technology aligned with business evolution. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.